Today I'm going to be talking about data science. We've got actually a nice day to celebrate. Oh, yes. So, if you look at Google Trends worldwide, just last month, machine learning has surpassed big data. That's it. Big data is done. Like, gone. So machine learning used to be a term that people would search for a long time ago, but from January 2012, big data took over. You can see the hype is over. That's it. It's asymptotic already, and the machine learning. So I guess what it means is that everybody has collected some data by now. They are calling it big, definitely. And now they're trying to figure out, okay, what do we do with it? And the ball is on the data science and the machine learning part of the organization. So I feel a lot of the companies that are really learning what to do with this artificial intelligence trend, the machine learning, the big data, looking at the competitions like Netflix competition, Kaggle later on, it became very famous among the community. And the competition has the framework. The framework is very simple. You've got the data prepared. Most of your time you spend looking at the feature generation, training the model, cross-validating, all of this, and then you ship the predictions. And you get the score, you either win or lose on some leaderboard. So if you look at it, you start hiring data scientists. That's what many organizations have been doing. Your favorite job title is data scientist. Then you land inside the organization, and I bet many of people actually had this feeling. Well, there is no prepared data. You have to clean it. I've been working in like e-commerce startups for a while, so I can, like hands-on, I can tell you it doesn't really look this way, but it definitely feels like this. Like you really are cleaning the data, and that's the most important part. So this is your new view of the world where, oh, the machine learning is just the tip of an iceberg. Actually, preparing the data is the most complicated part. And then you ship the predictions. And now your favorite job title is data engineer. You don't want to be hiring people who want to do complicated artificial intelligence. You want to be hiring data engineers. That's one piece of advice. If you're still hiring data scientists, think about whether you have enough data engineers. Everything starts to work beautifully. You've got the data clean, you train the model, you've got your super perfect prediction. Then you come the next day to the office. The question is, did anything change, really? Did anything change? Like, sometimes it looks like nothing is happening. I already solved it. Like, where is the change? The change is not coming. So if you've been through this cycle, you already know that actually execution is the real problem. And I don't know what is the job title for that. Like people were saying transformation, enabling innovation. It's much more complicated than that. Okay. So how do you do the execution? I don't know, but I have at least 3 pieces of advice, like 3 keywords that are really important to me. So the first one is decisions. Well, the thing is very simple. The data science, whether competition or academic view of the world, is predictions. You're talking about accuracy of your predictions. But the business doesn't need predictions. The business needs decisions. If the user comes to my website and my super fine-tuned machine learning algorithm tells that he's not going to buy anything, that's actually useless information to me. I want to know why, and can I do anything to make him stay and buy? I need some actions. I just don't need the prediction. I'm going to learn in 5 seconds because he's going to close the browser. That's it. You know for sure. No need to predict. This is where I believe the problems might start for certain data science machine learning projects. If you don't get the experts in the room fast enough, the Kaggle taught everybody that the domain experts are not really good for building predictive models. Like normally, everywhere from the Boeing competition in Kaggle to the Merck competition in Kaggle, the data scientists beat the domain expert teams. That's a well-known fact. The question is, if you want to make decisions out of it, you probably need to know which levers you can pull. Like if you're building some optimization for marketing, for targeting, you might learn up front which properties of the user are accessible through this AdWords or Facebook or the ad buying engine that you're using. So you need some domain knowledge to know the actions that's possible. And still, you need to be always thinking about decisions. Like my big picture is, you can, basically the whole business is about decisions. You can make decisions through data, or you can make decisions with gut feeling. And the current approach, I believe that we believe in the data world, I guess, is that making decisions with data is more efficient. But unless it happens through the whole organization and people start doing day-to-day decisions based on data more than on expert opinion and opinions, well, the whole investment in big data doesn't really pay off. So one is not predictions, decisions. The second one is trust. Do you trust the data? I remember last year, as I told already, I'm a big fan of this summit. Last year, there was a panel discussion, and a person stand up and asked the question. Business, and basically the question is not the question. The actual message is, business people need to trust the data. How do I make them trust the data? And I felt that this is like a common frustration with the data people. How do we get the business people to really trust that this data is correct? But I can, no.
It's very, very, very hard. Because you've got their opinions, and you've got the data. And if you get them to say the data is correct, then that kind of invalidates their opinions. So it's a very tricky.
They're useless in the end, right. So, but I can try to stand on the side of the business and say, yeah, it is sometimes difficult to trust the data, and specifically to trust the model when we know data is not clean, never clean. Like an honest data scientist never calls their data 100% clean. And then the whole model is a black box, and it's called black box, and even the data scientist himself doesn't understand how it works inside. It is kind of difficult. One pattern of behavior that I saw, and I think I have one piece of advice as a solution, is this throwing the models over the fence. Like once you build the model and it looks super fancy and you think it's working, data people, they tend to rush and say, okay, I'm going to publish it, now the business people are going to start using it, and you throw it basically over the fence without examining the insight that you can draw from the data. Then the business person, they don't care about the beauty of random forest and gradient boosting trees and all of this. They don't care. They look at the data trying to find something on the model and the results on the dashboard trying to find something surprising. And if they find, the first question that they have, is the data correct? Like I see and something goes like, is it the tracking problem or is it the real problem? And it creates the narrative in the whole organization, I feel, that the data is not reliable. Because it is always the first stop. Like, if I see something surprising, is the data correct? And the way that I saw it can be broken if when you're shipping the model, you also go like wear the business hat as well as the data hat, and go through the model, find the surprises up front, knowing that the business person is going to hit them, check that it's not the data problem, and ship it all together. The model plus already the first insights from it helps a lot, because then there is already some value from this model. It's already validated. In the email to all where you publish it, you already say that I checked. It is not the data issue. It is the issue, and data just sheds the light on it. It helps. Another thing that I know it helps is when you interpret. Well, black box is not normally interpretable. Many models that don't even have the functionality to say which factors went into it. But building tools that actually explain, at least at some level, which factors drew to this decision of the machine learning algorithm actually helps. So for example, yeah, this is like a made-up example, but we've built it I built it in the past. When you do a recommendation engine, maybe it's very complicated behind, the business person is going to come and ask, okay, this particular case cannot be right, like something is broken with this particular recommendation. So it helps pretty well, also helps debugging. When you have some built-in tool, like not available to users, but available to internals of the company, cheapering the decision and saying, okay, these were the factors that brought this product as a recommendation on top. Then the business person can see the logic, and if he thinks this product is awful, and then he demonstrates that actually by measurement it's like a rock star seller, maybe the picture is not nice and you just can see it, but the actual, I don't know what it is, or it says that the price is amazing now. So it explains a little bit the model decision. It helps to persuade the users. I really don't understand how McLaren can decide on, like the previous talk, how you can just listen to the model without overthinking and just put the tires everybody thought is wrong. So I feel most of the organizations need some explanation to why don't have enough trust into the model. And the third and the complicated part is deployment. When you want to bring your decisions, your predictions to production. So I feel visualization used to be the most popular way. Like, okay, we're going to build a dashboard. The dashboard, yeah, that's like, we have all the data clean. We are going to put it in some beautiful, maybe expensive visualization tool, and then everybody can explore the data. And yes, visualizations are super crucial, but too often I end up seeing and hearing the situation where the business person asks, can I get this in the table format that's just like my Excel previously? Yes, I close to home, right? And then the second implicit question is, how do I then load from this super visualized tool into CSV and paste into my Excel spreadsheet? So I want to own the data light physically. In reality, what I see when you really try to deploy something, machine learning models tend to overcomplicate the manual work. Like if you use, I don't know, you're optimizing some advertising campaign, like I'm going to follow, I'm from e-commerce too, so I'm going to follow the Zerg example of advertising. So maybe you're bidding in AdWords on 5 keywords. Now then you've got the person, the marketing manager, doing the job, just a few boxes and you need some predictions. Well, the value of your machine learning algorithm is probably going to come not from making a better prediction, but from increasing the complexity, adding cities, languages, device types, changing during the weekend, during the holidays, during the time of the day. So you've got so many boxes, cannot be done by person. So you think visualization, dashboard, and that's it. Doesn't work. You need to build a robot to change bits. Then you start, okay, where is the API from AdWords? How do I build an algorithm that is going to just change the bits there? And if you didn't plan for that and didn't resource that, you are stuck for months because this is a risky problem. Like, do you know what the McKnight Capital Group story? The McKnight Capital Group is the big and famous algorithmic trading fund that disappeared during one day. They had the code in testing, they pushed to production, nobody noticed the bug. They burned, through several hours, they burned through 60% of their fund. It's a famous story, Google. Now, this is the guy who is preparing to start sending out his CV. That's it, done. The company doesn't exist after that. Got acquired. They burned through 60% of the fund. Millions and millions and millions. This is the share price. It goes from 12 to 4 on a day. So now the question is, okay, Kaggle is very famous for the super complicated models because you're fighting accuracy. In production, what do you do, accuracy or robustness? Does anybody know what are these rifles? Yes. I have somebody in the room to get it. Yeah, so the M16 famous for the accuracy. Also, if you dig into the dirt, it jams. And A47, and they meet during the Vietnam War. A47 not super accurate, but it is difficult to break it. So it's going to fire rounds, doesn't matter what. That's the Vietnam War story, but it has relevance to us. Then another pitfall that you hit, so this guy is a CTO. And if it is R, it is even worse. You come, like if you are silent and there's a data science and you build your model without thinking how do you deploy it, and it is touching production, like AdWords, okay, it's somewhere there, like some isolated job that was done manually, probably you have some independence. If it is production, if you're talking, I don't know, in banking it should be transaction, and e-commerce should be the main website, the CTO is going to say, no. Python, I can see so many CTOs cringe when you come with your Python model. R is even worse, as I said. So there is no good solution. Well, there are solutions. So we've gone through many things. I've tried every single one of them. We deployed something, and there are pros and cons. Like you can do microservice, it's very famous, also slow. We tried PMML and all other standards where you can build a model in Python, explore it, deploy Java, or deploy C++, compile. Difficult, it exports the model, the feature cleaning part it doesn't, you need to recode it, difficult. You can rewrite everything in Scala or Java, it gets also super simplified while you're doing this, or whatever is your preferred production language. And actually the most ugly I can admit, but the most used model is just a VLOOKUP table. When I say, okay, I'm going to reduce the number, I see it's close for home for some people, right? I just reduce the number of features and I generate the predictions and okay, pull it overnight, get to your Redis ready for everybody in memory, and then the production pulls from there. The vaults don't touch. And my own timekeepers, sorry. That's difficult. But I think, yeah, for this slide, I feel there is room for improvement, and I feel this is where I wait for the startup to come or the big infrastructure company to start doing more. Probably everybody is doing something. I definitely saw in the last WWDC from Apple that they are bringing the MLKit to the iPhone, so you can do certain machine learning stuff. On every iPhone on the consumer in the app, you can use their algorithms optimized for the hardware. Well, that's something. If you're in native apps, you probably can use it, can start thinking about using it. The famous hot dog, not hot dog app from the Silicon Valley. The speaker before mentioned the Silicon Valley sitcom, right? That hot dog, non-hot dog app is not using that because it was built before it was available. So it actually warms up your phone very fast. You can warm up your hot dog with it, like if you tried using it. It's the app that they actually wrote, you can download for the movie, for the sitcom, that recognizes the hot dog, and also it recognizes the not hot dog. Everything else. So these were the 3 points: the decisions, the trust, and the deployment, and a little bit of my journeys and the pitfalls that I've been falling into, trying to deploy. But what is my bigger view on the thing? I'm not sure if you saw this comic. So Harvard Business Review coined the term that the data scientist is the sexiest job of the 21st century. And then Nuggets posted this saying that we think by 2025, it's automated, and the job doesn't exist. The data scientist is automated. Maybe before the truck driver is automated. Because their timeline is actually like the 2030 or something like that. Depends on the company promising. I don't think it's going to happen. Well, I don't think the automation is going to be the doom. But I do think that just the job title data scientist probably doesn't exist by that time. What I see now is, okay, we've got all these departments and there is the data science siloed somewhere, and it creates all these problems with deployment. And actually, getting the data clean is super automated. The tools are getting, like, from how you think about Hadooping stuff out of things 3 years ago, 4 years ago. By now, it's so much easier. The automation of data science tasks is extremely fast. So you used to be very, very knowledgeable about which algorithms to choose, where is SVN, where is random forest, where is linear regression applicable, and then all the hyperparameters you need to tune. And now, no, you don't do any of this. The algorithm, the computation is so cheap. You just try everything and find out which one works better. So there is a lot of automation inside, but one thing that is not going to happen is how do you get it to work inside the organization? So my prediction, I'm not sure if you can catch me on that, several years later, is that data scientists really marches across to different fields and start specializing in things, because it's so difficult to get the marketing department to get the trust, to have the skill, to trust the data, that it's going to be a mix. It's either you're going to have the marketeers learn a lot of data science, or you've got the data scientists march across and be the marketeers. So it's the new world. You still have the silo where it's like getting the data ready, the data engineering part, but the data scientists are across everywhere. So they're disappearing by taking over, or so you need HR where you have decisions to make. You either get the person there who understands data science, or the data scientist marches over and starts making the decisions and building. If you're starting building the models instead of making the decisions manually on certain things, then what you need in HR is a data scientist who observes the model, not the person who is deciding. So like in the McLaren case, I think they're kind of past this term, because there was no person, as I understand in this talk, there was no person telling how much fuel and which tires. The machine told that, right? So there is a person, a data scientist, replacing the builder of the model, but he is not in the room, right? In the room during the race. He doesn't need to be there. He can be sitting somewhere else because this decision is automated. A friend of mine who is a recruiter, he is telling that there was a very hot job title, the head of digital marketing, some time ago. Not anymore. Because your CMO is supposed to be the head of digital. Digital has taken over, right? So my feeling is happening with data science as well. It's just going across everything in the organization. And it's definitely not siloed, and it's just taken over, because the key is to make decisions with data, not with gut feeling. Thank you. Have questions? Come on.
It's very interesting when you say that at the end about the key to making decisions with data, and it's something that I really like your narrative about going from needing data science, to needing data engineering, to needing execution. I won't repeat that, but I really like the narrative about going from needing data science to needing data engineering to needing execution. I'm very interested in this element of how do you get the value, and one of the questions that comes up a lot is when you're even naming yourself a data scientist or a data engineer or a data person, to me sometimes that language already
has this idea that you're looking down at the data, looking down at the tools, rather than looking up at the problems. So when you're trying to get value and answer people's questions, is there a sense that that's already constraining your thinking, or you're not doing that, if you're actually starting with the idea of where's the model, where's the data engineering, where's the data science, how do we use our tools to solve the problem, rather than how do we talk to our users, which comes back to the trust point that you're talking about. How do we gain that legitimacy? How do we gain that credibility? How do we have that mixture of domain knowledge and technical knowledge? And can we start from there more than by starting at the lower level and starting with the data and asking what do we do with this, rather starting with the question and ask how do we answer that? I know that was a kind of rambling question, but I think that's typical of where we are in this state at the moment. How do we merge together looking down at the data and the technical things, but not being obsessed by that, and instead keeping our minds clear to answer the questions that are coming down from the top?
Yes, so for me, I think it is easy. I can't make sense of the data if I don't understand the bigger picture of the problem. So I feel, and that's what I'm trying to teach everybody in the team, like look up, right? Look up. And I think this one is working, but you need to be really hard on selling it inside the organization, like getting everybody on board, because there will be people not trusting the numbers, having their own opinion for various reasons, right? And you need to be able to sell it, and this is where the trust and you're becoming a salesperson. And I think somebody else told exactly that already, right? You're becoming a salesperson inside the organization, and you need to be really hard sometimes showing that, demoing, and there is always, my favorite tool is, okay, let's A/B test that. So, and I'm trying to bring it as much as possible to the data level. But I don't know. I'm not saying that I know the right answers to all of it, because it is hard. It is hard. You need to have the two people to dance.
I think it's a long-term cultural change that you have to bring about. It doesn't start right away.
Yeah, it doesn't start right away. It's a cultural change that you have to bring about, because in my experience, the first thing is people come to you with tasks. And then once they have confidence in your decision, you start to say, hey, let's jointly solve problems. So one has to come before the other. And when you start to jointly solve problems with the stakeholders, you express interest in their business, then things start to transform. And the final stage is, sometimes the business so well and the data, you can actually come to them with solutions to problem or opportunities that weren't even problems. You say, hey, this is really cool. You might like this. So it takes time. It takes, I don't know, I hate to say it, probably a couple of years to bring about that transformation in a business. Really have to be persistent.
Yeah, I could say that my most successful projects would be with the people and the parts of the organization where I would get them inside, very like in the beginning. I would keep talking to them through the whole process. Like if you're doing something for the marketing, your lunch should be with the marketing guys. Like if you're doing something like we're doing for integrations, yeah, your lunch is for that period of time. Your lunch is with the integrations. You want to breathe with them. That helps. More questions?
Hello, Borja, from Julius Baer. I have one question, maybe it's a bit philosophical. I'm imagining now the future where I go to a shop, let's forget now the digitalization, and I exactly find the products I'm looking for because they know me so well that I don't need even go through the supermarket. So it's like a basket with all the products I'm seeing that are exactly what I'm looking for. If we reach this situation, which is what we are looking here, where is the chance that meanwhile I walk in from the supermarket, I find and I buy some products which I was not really on my mind. So it's not predicted. So maybe we are trying to go to understanding so well the client that maybe we are losing a bit, that is this kind of random of decision that we cannot see when we know this client is my name is Borja. Borja is Spanish. He likes Spanish food. And suddenly this guy lost the opportunity to buy maybe Indian food, which is delicious. So it's a bit of philosophical, but it's only when this kind of data science is where we are going now, or what is the goal of that, or what is the limitation that we can have when we have all this information. Thanks.
Thank you. I really hope that this is just the current stage of these recommendation engines, and they're not sophisticated enough. Like internet sometimes reminds the echo chamber, like you type the fridge and then everything is a fridge, right, across, like you go anywhere, but you already bought it. So the system is just not sophisticated enough. They're paying for it. It's a lot of money they're paying to advertise this. So there is actually the incentive on the advertiser to understand this better, to stop when it's not needed. And just many algorithms are not sophisticated enough. Not all the players did it. And the same to your point. Well, in Vigo, in my previous company, we actually had it in an algorithm. Like you've got a new hotel, like it was a travel, you've got a new hotel, we are going to surface it, we are going to just show it. So there is a certain element in your basket that is random, that is more like, maybe, let's give it a chance. There is always a chance. And it works. It's like the exploitation dilemma, where you don't want just exploit the data, but you also want to explore, extend it to areas where I didn't try this on you yet. Like, maybe I'll try a little bit. But it is difficult. If you want to bring it into your algorithm, it makes the whole thing super complicated. Then robustness kicks in, the one that I mentioned. So it takes time to get to this stage. I think it is going to happen. It's going to be that balanced. More questions? Thank you. Thank you.